Welcome to this brand new explainer. I am absolutely pumped about today's topic because honestly, we're looking at a fundamental shift in how human beings interact with technology. For decades, right, if you wanted to build software, you basically had to think like a machine. You had to memorize syntax, fight with compilers, and spend hours hunting down one literally invisible missing semicolon. But today, we are right in the middle of an AI paradigm shift. We're moving away from the rigid rules of syntax to a beautifully orchestrated symphony. We're shifting our whole mindset from being a traditional programmer to becoming a creative director. Let's get right into it.
So, think about this for a second. What does it actually take to build an app today? Historically, the barriers to software creation were just massive. You had the total friction of manual server setups, the nightmare of database configuration, and that endless, soul-crushing loop of syntax debugging. If you had a killer idea but didn't have years of computer science training under your belt, that idea usually just died on the vine. But that reality, it's completely gone.
Okay, let's dive into this. This right here is where the magic happens. Look at the traditional coder role. It involves this incredibly high cognitive load, worrying about every single line of code, managing server infrastructure, troubleshooting constant errors. But in this new era, your job is completely different. You step into the role of a creative director. You describe your vision, critique the output the AI hands you, and iterate on the user flow. It's kind of like making a movie. We no longer have to be the person holding the boom mic or adjusting the lighting rig. We get to sit in the director's chair and guide the entire film crew to bring our vision to life. Section 1. Inside the AI engine. How LLMs think. So before we can effectively direct our new AI crew, we kind of need to know how they operate under the hood. The secret sauce behind these large language models, specifically the ones using the transformer architecture, is a little thing called next token prediction. Rather than following strict grammatical rules, these massive neural networks are trained on mountains of text to simply predict the most probable next piece of a word, or a token, based on the context that came right before it. And what makes this so incredibly powerful is the self-attention mechanism. It literally allows the model to read entire sequences of words simultaneously. It assigns attention weights to conceptually related words across super long contexts. So it's not just guessing blindly. It's using deep contextual awareness to figure out exactly what should logically come next. Now, to pull this off, the AI has to translate our text into numbers. Early models tried word-level tokenization. And hey, this is highly intuitive for us humans, but for a computer, it's really brittle. It leads to a massive vocabulary explosion because the model needs a ton of memory to store every single variation of a word, like run, running, and ran. The alternative to that was character-level tokenization. That solves the memory problem because the alphabet is tiny, meaning no out-of-vocabulary words. But you completely lose the local semantic meaning. A single letter R doesn't really mean much on its own, so the model struggles to understand the broader context. Basically, both of these approaches fell short. Now, what's really interesting about this slide is how the industry finally solved this. They used something called byte pair encoding, or BPE, which perfectly balances the vocabulary. BPE starts with individual characters and then, iteratively, merges frequent adjacent pairs. The result? A manageable vocabulary of around 30,000 to 100,000 tokens. If it encounters a really common word, it keeps it whole. But if it encounters a complex or unfamiliar word, like unhappy, it elegantly splits it into recognizable subunits, like un and happy. This right here is the industry standard that allows our AI crew to understand our instructions so flawlessly.
Section 2. Controlling AI creativity, the probability engine.
Okay, now that the model has translated our words and scored the vocabulary to predict what comes next, we get to step back into our role as the creative director. We actually get to adjust the dials on exactly how creative our AI crew is allowed to be. You'll often see two critical settings here: temperature and top P, which is also known as nucleus sampling. Let's focus on temperature. If you set it to 0, the AI uses greedy decoding. It will always pick the single highest probability token. This is exactly what you want when you need strict facts or when you're generating code, because absolute consistency is paramount. But if you move that up to a balanced 0.7 or 0.8, the AI starts letting lower probability words into the mix. That's your default for a creative, engaging chat. Now, if you push that temperature above 1.0, you're telling the AI to take high risks. It gets super creative, but often veers straight into total nonsense. And right alongside this, top P acts as a safety net. It limits the candidate token pool so the model can't choose absurdly low probability words, ensuring we maintain that creative freedom without going entirely off the rails. But here's a truly surprising fact about these settings.
Even if you demand absolute predictability and set your temperature to exactly 0, you might still see slight variations in the output. Why? It's called GPU non-determinism. Because graphics processing units calculate math in parallel across different threads, the operations don't always sum in the exact same mathematical order. Add in concurrent server batching, and your exact same prompt might actually yield 95 to 99% similarity rather than 100% bit exact determinism. It's a tiny variance, sure, but it's a fascinating quirk of the sheer computational power running our AI crew. Section 3. The vibe coding mindset. So, understanding these micromechanics, how the AI reads tokens and calculates probabilities, perfectly sets us up for the ultimate macro creation paradigm shift. We have literally entered the era of vibe coding, where simple, natural language prompts allow anyone to just describe their vision and deploy fully functioning web applications to production in minutes. So the crucial point is that you no longer need a computer science degree to bring your ideas to the world. Natural language prompts have entirely democratized the app lifecycle. Whether you're a non-technical entrepreneur, an educator, or small business owner, anyone with a vision can now describe, critique, and iterate their way to a working application.
And by the way, the apps we're building using vibe coding, they aren't just simple static pages. Modern apps are expanding way beyond those traditional CRUD flows. Create, read, update, delete. We are now building applications that incorporate dynamic agentic reasoning and LLM orchestration, meaning the software we design acts as a truly intelligent system driven by AI logic, capable of interacting dynamically with users and data. We aren't just building flat databases anymore. We're building smart, reasoning systems. Section 4. Building apps with Ajath. Let's move to and see how this builds out as we look at exactly how this paradigm shift is applied today in 2026 using a leading platform like Ajath.us. When you use a platform like this, you aren't just chatting back and forth with a single, easily confused AI. Ajath features an incredible multi-agent engine. It orchestrates up to 10 parallel agents with names like Maya 4, Reina, Jacob, and Matt. And they are all working at the exact same time. One agent is handling the front-end UI, while another is designing the database schema, and another is locking down secure authentication. Having multiple agents working concurrently like this completely eliminates those painful sequential debugging loops we saw in older AI interfaces. You are the creative director, and this is your highly specialized parallel processing crew. And this brilliantly illustrates the infinite canvas. Think of it as a visual development environment that ties visual components directly to the underlying code. You aren't just staring at a text box, you have a high-fidelity design playground where you can visually tweak layouts, drag elements around, and critique the design. And as you make visual changes on the canvas, the AI agents update the code pipelines in real time. It is literally the ultimate expression of designing and iterating without ever having to touch a line of syntax yourself. Now, to make this whole process completely frictionless, vibe coding relies on zero setup infrastructure. You instantly get pre-configured full-stack hosting, instant databases, secure authentication, and over 100 API integrations for things like Stripe, OpenAI, and Google Workspace. You don't have to be an infrastructure expert. You don't have to worry about provisioning servers or managing deployment pipelines. You simply vibe code your app on the canvas, critique the output until it perfectly matches your vision, and instantly receive a live, shareable URL to production. The heavy lifting is entirely automated. So, we've explored the incredible mechanics of next token prediction. We've seen how parallel AI agents can build complex software, and we've learned how the infinite canvas empowers you to be a creative director rather than just a syntax debugger. The technology is here. So now that the barrier to entry is totally gone, what will you vibe code today? You have the power to direct your own AI development team and turn your imagination into reality in a matter of minutes. Embrace this new mindset, start experimenting, and let your ideas fly. Thanks for hanging out with me on this explainer, and honestly, I can't wait to see what you build.